All right, so we're looking at our 2.2 homework on exponential versus linear growth. So we're going to determine, based on this XY table, is it linear, exponential, or neither? So we're going to have to just refresh, remember what linear means. Linear, as we know, we've learned it's kind of like arithmetic or arithmetic sequence. I spelled that wrong. Hold on. There we go. Linear arithmetic. So remember, it's like the pattern is that common difference, right? Basically, the pattern is we're adding or subtracting. We're going to be adding or subtracting for linear. The flip side is exponential. Which remember we made the connection is it's similar to a geometric sequence. Right? So what's happening for the pattern with that? For a geometric sequence, remember that's our common ratio. And what's going on just in general is we're either going to be multiplying or dividing is the pattern. All right. Please hold. Let me jump over here. All right, so let's look at what's happening for this given problem. So we've got our XY table. Remember too, for the X values, we're kind of not really concerned with the X values when we're figuring out which type of growth it is. We're primarily focusing on our Y values. So I know it looks kind of weird here because it's not our standard X values where it's like 0, 1, 2, 3, right? But we can check and see if the X values should still have the same difference. Looks like maybe 9. So -5 and 4. So -5 and 4. So +4, right? We clear that out. Oh, there we go. Difference would be 9. Let's see. 4 plus 9, 13. Let's see. -5. Let's check. Plus 9 should be 4. Yep. And then one more, 13 plus 9. Yep, 22. So for all of the X values, it's increasing by 9. But remember, we don't want to use that as what we're referencing for the bunny hops because it's always going to be the same, right? Usually it's 0, 1, 2, 3, etc. Right? We don't want to reference that. We want to primarily focus on, we're zeroing in, we're locked in, looking at the Y values. So we're going to go ahead and just highlight them to make it super abundantly clear. We are focused on the Y values only. So let's see, going from 7 to 14 and 14, 21, 21, 28. We're like, that kind of looks interesting, right? These numbers look familiar. So we can check with the calculator and just see. Well, we know 7 times 2, times 2 is 14. Let's see, 14 times 2, does that give us 21? Oh, not quite. And then times 2, does that give us 28? Nope. Okay, so maybe not multiplying. We're seeing any other patterns. Jumping from 7 to 14. Well, 7 plus 7 is 14. Let's see, plus 7 is 21. Let's just double check. Plus 7 is 28. So we can notice that the pattern, what's happening here, is as we're bunny hopping, jumping from term to term, we're adding 7 each time. So because we are adding, it's going to need to be linear because the pattern is addition. Linear, perfect. Let's try another one together. All right, so same idea. We're not really concerned with X. It looks like the difference is 5. We're adding 5 each time, but we don't really, not that we don't care about X, like, X is still important, but for the purposes of this video, of this topic, we're just locked in on Y, only looking at Y. And again, we're seeing, okay, bunny hopping, right? This calculator is pretty handy. Let's keep that open. Can I have that open with this? Ooh, I can. Cool. All right, so comparing 1 to 2, right? That's 1 plus 1 is 2, but then it has to keep that same ratio. So plus another one is 3, not 6, right? And then plus another one is 4, not 12. So it looks like addition is not working. So let's try multiplication. How do we get from 1 to 2? Well, 1 times 2 gives us 2. And then it has to have the same pattern. So times another 2 gives us 4, not 6. And then times another 2 gives us 8, not 12. Right, so 1 times 2, and then times 3, and then times 2, right? It's like, what? Like, that's trippy. It wasn't consistent. Remember, for linear and exponential, the pattern has to be consistent throughout all the sequences, all the terms. So this is an example of what would be neither, because we're not multiplying, dividing, we're adding, subtracting, so neither. All right, let's look at one more. Hopefully this one's a little different. Hopefully. Let's get our calculator out. So again, we're focusing on the y values, just locked in looking at y, and we're doing those bunny hops. We're seeing how are we jumping from term to term, right? An observation we can make is we're starting off with 2 and we're ending up with 48. That's pretty significant, pretty large. It looks like we're going to be multiplying. So 2 times 2 gives us 4, and then times 2 would be 8, and then times 2 would be 16. What? Another one? I'm surprised. I'm shocked. All right, so 2, 4, 12, 48. Right, how do we get from 2 to 4? Times 2, but then times 3, and then times, is that 4? Yeah, times 4. So this is kind of interesting. 2, 3, 4. I'm guessing the next would be times 5. But we haven't learned these ones yet, so this is another. All right, let me see. We're gonna do all of them. Okay, this one's another linear, but I wanted us to see another exponential. But basically, exponential, you're just seeing the pattern will be abundantly clear where we're multiplying or dividing consistently the same number throughout each term. All right, use this video to reference while you complete this homework assignment. As always, any questions, email, text, let me know. All right, good luck, guys.